The substance of my talk, I have to get logged in, and we'll see whether or not Mr. Gates actually works here. That looks like a good start. First of all, I want to explain the garb. My title at Google is Chief Internet Evangelist, and it seemed to me that some kind of ecclesiastical regalia would be appropriate to that title. But this is actually the formal academic robes of the University of the Balearic Islands, where I was honored with a PhD degree several years ago. And you all remember that in Latin it's honoris causa, and that is roughly translated, you didn't earn that. So, but very, very generously, they offered to let me keep these wonderful robes. And it's not common that I would have an opportunity to appear in such garb, but Educause struck me as having academic roots, and therefore would understand why it was appropriate to be so attired. Lawrence Valverde, who is the chair of the Computer Science Department of the University of the Balearic Islands in Palma, Mallorca, is actually here today. I haven't seen him, but if he will identify himself, I hope you'll come and express your admiration at the spectacular robes that they use for their graduation ceremonies. In fact, I remember when I was teaching at Stanford University, as many of you will know, every year you have these graduation exercises, and the faculty dresses up in their academic regalia. And I was wearing, at the time, this is 30 years ago, rather drab-looking black robe with a square hat. And in front of me was the university professor of mathematics, who got a degree from the University of Madrid. And he wore a flaming red outfit with this great floppy hat. And I had regalia envy for years. I don't feel this way anymore. Now, I also need to say something about this splendid arena in which we're meeting. For me, this has been an unusual week. I'm in 5 cities in 5 days. Yesterday, I was in Fargo, North Dakota, with Senator Byron Dorgan, expounding on Internet in the Fargo Dome. And so I've been in 2 arenas in 2 days, and I'm beginning to wonder if I shouldn't do some kind of a revival thing to go along with all of this. I've also been asked by my colleagues at Google to slip in a subtle way, which is not what I'm doing right now, a comment about something called Google Apps for Education. We've released a set of applications which we'd like to make available to all academic institutions. They include Gmail, Google Docs, and Google Calendar. We have some 2,500 institutions which are now using these technologies, so I would offer you a chance to go and investigate whether or not those applications would be of some use to you. Well, let me move ahead now to the substance of what I'd like to offer this morning. This is not a traditional networking talk at all. I hope that I can, in fact, challenge you and your colleagues, and especially the members of the computer science faculty, to take seriously a challenge which I think has gone unmet in the history of computing. So let me start out just by briefly mentioning the statistics on the net, just to keep you up to date. There's over 400 million servers now on the network and over 1 billion users. They are embedded, however, in a telecom environment that has 2.5 billion mobiles. This is a stunning achievement, because 10 years ago there weren't very many at all. The reason that's relevant to us is that those mobiles are often Internet enabled. And so increasingly the Internet and its applications, and the ones that you might care about for delivery of academic material, will be reached through these mobile devices. So we need to think about how to present material in these constrained conditions. The actual distribution of use on the net is changing also. You can see from this statistic that the absolute largest fraction of Internet users today are in Asia. It isn't surprising when you think about China and India and Indonesia and Malaysia, Japan, and so on, are all lumped into this regional category. There are something like 56% of the world's population in that region. They now account for some 380 million users on the internet. And of course, that will influence the content that's on the network. Even though today a very significant fraction of it is in English, over time we're going to see the other languages of the Asian region predominate. So you should be prepared for that. Well, let's start out now by asking ourselves some tough questions. The term computer science implies that computing is a science. But there are things about the scientific method which I suggest don't apply to computer science, so I'm not sure that we've aptly named this particular domain. Normally, in the scientific method, you develop a theory, you predict the results that theory implies, then you make some measurements to figure out whether or not the prediction is met, you compare it, you publish your results so that other people can reproduce the experiments, because if they can't duplicate them, then it isn't clear that either your measurements or your predictions are accurate. And then you iterate until finally all of the predictions and the theory and so on match up. So the question is, what can we predict in computer science? Is there anything we can predict other than sheer chaos? Now, I should also point out that hardware has improved its cost-performance ratio by many decimal orders of magnitude since the 1950s. I mean, it could be 6, 7, 8, 9, maybe more decimal orders of magnitude. A tiny little example of this. Not too long ago, I purchased a terabyte of memory for use at home. It cost me about $1,000. And I'm sure some of you will tell me I could have gotten it cheaper at Fry's. I remember buying 10 megabytes of disk memory in 1979. Perhaps some of you did too. It was about the size of a shoebox. It cost $1,000. So I did a little math and said, well, how much would a terabyte of memory have cost in 1979 if I had to pay for it at 1979 prices? And the answer is $100 million. Well, I guarantee you that in 1979, I didn't have $100 million to spend on it. And if I did, I'm sure my wife would not have allowed me to spend $100 million on a terabyte of memory. So memory, as an example, has benefited from Moore's Law, as have the computing systems that we have today. But I would suggest to you that the only value we've gotten out of that in the computing sense has been brute force, which in the past might have been ineffective because it was too expensive. Now we can actually afford to do things by brute force. And in a sense, what Google does takes advantage of that, because in order to do what we do, to index the entire World Wide Web, we actually use hundreds of thousands of computers that we build ourselves and put into these big data centers scattered all around the world. And I don't mean to suggest there isn't any cleverness in the algorithms we use, but the point is, to do what we're doing, it would only work because we have access to such a huge amount of computer power at reasonable cost. But we're not doing very well with programming efficiency, in my opinion. At best, a factor of 10, probably less over the same 50 or 60-year period. The high-level languages, Java, Ajax, Python, and so on, have helped some. But in my view, we haven't done much to improve our ability to produce software, at least in the same way as we have with hardware. So what kinds of things can we predict? Well, we've got complexity theory, we have analysis of algorithms. We can talk about the memory requirements for an algorithm, we can talk about the computing requirements, how many cycles are needed. We can talk about how long it takes to perform a computation. We can do a pretty good job of analyzing languages and say how long it takes to parse them, how much memory is required, or whether it's a push-down stack algorithm or not. We can talk about how long it takes to analyze the grammar of an expression in a programming language. We even have pretty good network models using queuing theory, some of which was pioneered by Len Kleinrock at UCLA and others. Although it's still arguable that these are abstractions from the actual networks that we build. And so at best, we're predicting approximations, we're predicting averages, we're not too good about predicting time-based results. Decidability and computability have very solid theories underneath them. We can talk about what expressions are decidable, what questions are decidable, what things are computable. And we even have some pretty good results with optimization. We've got some improved algorithms that allow us to invert matrices and calculate optimum choices of parameters. But there isn't much else that I can think of right off the bat. Now, we'll have some opportunity to chat after I'm done with this formal part of the presentation, so maybe you'll have some ideas that we should express about other things that are predictable in computer science. But I would say that there are a bunch of things that we don't predict very well at all. How long will it take to complete a program? Usually, the first 90% of the program takes 90% of the time, and the last 10% takes the other 90% of the time. How long will it take to find bugs in a program? And how many bugs will we find? Do we know? Do we have any prediction at all? We might have some empirical results, but we don't have any good theories. We don't even know why there are bugs. Is it because we don't know how to program? Is it because we don't know how to express what the program is doing? Is it because we're stupid? I don't know the answer to that. Do we even have any ability to say, does the program do what it's supposed to do? Or worse, does it do something it isn't supposed to do? Which, by the way, is one of the big dangers in downloading software off the internet. You might get a program which appears to do everything that it says it's going to do, but it doesn't tell you the other stuff that it does that you didn't know about. This is sometimes called a worm or a virus. In fact, can we tell if a piece of code is a worm or a virus? Gödel and Turing tell us it's hard to make any algorithmic decisions about what a program is going to do. But still, we need to find some ways of detecting these things. Can we even tell whether a message is spam? And people will argue that some messages that you think are spam, other people think are an interesting thing to read. Generally speaking, spam filtering has been more successful than I would have expected. Personally, I think that we have a very simple algorithm for dealing with spammers. They make money doing this stuff because it's a very low cost to send hundreds of millions of messages out on the net. So I think what we should do is we'll form a small consortium, and we'll let it be known that we're interested in using the spammers' facilities to pump out, some information. And when we find out who they are, we reinstitute the practice of public flogging. And after a few YouTube videos come up, maybe they'll get the message that people don't like spam. Well, you can make up your own list of things that we don't know how to do in the software world, in the general world of computer science. And that bothers me a lot, because computers have been around now for 60 years plus, if you don't count Babbage and some of the other really early pioneers. And yet we still don't have a very good handle on how to understand the performance of these complex systems. What about security? Are there holes in the operating system? How can we tell? Just because you didn't find a bug doesn't mean it's not there. Does this router have vulnerabilities? Does it know how to detect that an incoming packet is malformed? Can this network be used to attack itself? I mean, we actually have an autoimmune problem in the internet today. If you've followed any of the reports of what's called a distributed reflective denial of service attack, you know that the domain name systems components themselves are now being used to generate a magnified attack against the target. And it all starts with packets whose source identifier, source addresses are fake. They're actually the address of the target, not the address of the originator of the packet. And without going into a whole lot of detail, it's possible to ignite a very large attack by having lots and lots of resolvers send answers to a party that didn't ask the question. And so a few packets can be turned into tens of thousands of them, overwhelming the target. Now, I suppose some of you are sitting there thinking, well, what are you complaining about? You helped to invent this stuff. It's your fault. And oh, by the way, the little canard about Al Gore, just to set the record straight, he actually did something very, very useful as a congressman and as vice president on the legislative side. And so, A, he's a friend, and B, I acknowledge that his contributions were actually quite helpful. However, coming back to this problem of what did we do wrong? Well, one answer is we didn't put enough authentication into the Internet's architecture, and we should rethink that. Now, in defense, I will say that at the time that the Internet standards were completed in 1978, which is basically what you're using today, public key cryptography, which is the most obvious tool for doing authentication, had only just been published in 1977, and RSA had not itself been invented at the time that we standardized the Internet protocols. So that was a horse race that, in a sense, we lost. What about things like routing tables? What if somebody asserts that my network can route this particular address space, but they really can't? That can turn into a black hole. That can turn into traffic that gets diverted to the wrong destination in the Internet. Once again, we're back to authentication. How can I be sure that the information that I'm getting is valid? The same thing is true of domain name responses. When you look up a domain name, how can you be sure that the domain name system is responding with data that's in fact valid as opposed to someone who's faking it? Well, all of those techniques, all of those problems have a potential solution in digital signatures. And we've been using this phrase, digital signatures, for ages. Finally, we're getting somewhere. You'll be hearing announcements about the domain name system and the use of public key cryptography and digital signatures in order to validate entries in the domain name system. And there's work going on in the IETF to look at the possibility of registering IP addresses and digitally signing the information about to whom those addresses have been allocated, so that when you're getting routing table updates, you can figure out whether or not that particular autonomous system actually has the authority to announce that particular network address space. In fact, the hardest thing about figuring out what's gone wrong in a network is the configuration of its components. I can't tell you how many times problems have arisen because somebody configured a router or configured your email system or something else incorrectly. The trouble with configurations is that they're not obviously wrong. If there's a parameter that's obviously out of spec, that's easy. That's almost a syntactic check. But if you have a large range of potential parameters in a very complex set of configuration items, it's almost impossible to figure out that somebody did it wrong. You can figure out that it's different from what it was before, but that doesn't necessarily mean it's wrong. We need to find better ways of identifying some of these problems and fixing them. And until we do, we will have a relatively unstable environment in which our software is working. What about information management? Surely we've learned something there. Many of you will have heard Tim Berners-Lee's work on semantic networking, or the semantic web. He's very interested in finding ways to tag the contents of things that show up in the World Wide Web. And we at Google would certainly appreciate having that capability because it would improve our ability to respond with relevant information. A small nutshell example, the word jaguar is in fact ambiguous because it could mean a car or it could mean an animal. And when someone types jaguar to the Google browser or search engine, we don't know ahead of time whether that person is interested in the car or the animal. And moreover, when we've indexed contents on the net and found the term jaguar, we don't necessarily know whether or not it was referenced to a car or an animal. If it was marked as animal or marked as car in the text that we were working with, tagged in some fashion, then we'd be able to distinguish the two. And if we could find out from the person making the query, are you asking about cars or animals, then we could respond only with animals or only with cars if that was the intent. Now, all of you will remember the early stages of web development when you had to manually construct the HTML. It was pretty fascinating to watch how many hundreds of thousands of people became webmasters by copying other people's HTML. And the reason they could do that is the browsers allowed you to see the source of every web page that happened to catch your attention. So people could duplicate and learn how to use HTML simply by looking what other people had done. So this is a viral spread of knowledge about how to do HTML. I can imagine that tagging of the kind that Tim Berners-Lee is talking about might have to be manually done in the early stages, and so not very much of it would be produced. But just like the case of web pages, we've made automated tools that generate XML and HTML. Maybe we can make more automated tools that will help tag content on the net as it's being produced. There's another thing which I'm frustrated by. It's easy, or easier, to create indexes for textual material, but it's very hard to create an index for sound and for imagery and video. We don't have very good tools for saying, find other images that look like this. Find me a video that looks like that. We can certainly help you find videos that have certain content if they happen to, for example, to have been captioned, because we can get text from the captioning on the system and then use that as an index. So for newscasts and things like that, we can actually do a pretty good job of indexing the content. You say, I'm looking for a newscast about a particular item, and we'll be able to help find a particular video clip that has that information on it. But if we're just dealing with the raw video or raw imagery, it's much, much harder. And I don't think we have very good tools yet for making a better job of that. Another thing which is interesting is that we made heavy use of location as an organizing paradigm. In the case of Google Earth, we make very heavy use of the fact that people know where things are, and they can tell us where those things are. We can index content on the net according to where it is, and then present it, for example, as an overlay on top of the images of planet Earth. In fact, we even have a Google Mars, which is possible, although there aren't too many people telling us a lot about what's going on there yet. So I'm thinking that geolocation has become a very important organizing paradigm for a great deal of information. I'd like to suggest that time of day, or the moment in time when something happened, is equally powerful. And we probably use that less well as we have geoindexing. And so my suggestion here is that as we think about how to organize information in a more powerful way, that we should include the time dimension as well as the location dimension. And maybe there are other semantic organizing concepts that we can use. Is this information about a particular topic? Is this information about medicine? Is it about physics? Is it about chemistry or biology? There may be some semantic axes along which we can organize information. You'll be familiar, some of you I'm sure, with the medical subject headings that are used at the National Library of Medicine to index articles that have been printed in refereed journals. That medical subject heading indexes a controlled vocabulary, and both the indexer and the people who are searching for things use the same words in order to make reference to documents of interest to them. The side effect of that is that you find a higher probability of match because you're using the same vocabulary to refer to items of interest. I'm very concerned, and I've been speaking more frequently now, about what I'm going to call information decay. I mean, it's kind of like tooth decay. I mean, if you don't brush your teeth every day, eventually your teeth fall out. It seems to me that there may be a similar problem with the information that we're accumulating. Think about all the digital information that's becoming part of our environment. Over a period of time, let's say measured in hundreds of years, we may have less and less ability to interpret the bits that we've stored away. We may actually be able to copy the bits from one recording medium to another as new recording technologies come along. Preserving the bits themselves is not the problem. The question is, what do they mean? When we create digital content, it's almost always in the context of a piece of software that helped us to create it and helps us interpret it. If we don't preserve the software, it's just a bag of bits. And over time, it may be that preserving the software isn't enough. We need to preserve the operating system that the software ran under. Well, this is starting to edge into intellectual property territory and questions about who has access to software and under what circumstances. Over a very long period of time, we may need to find new ways of assuring that people who create and maintain software and then stop maintaining it have mechanisms for making that software available to all of us so that we can make use of it when we're doing searches and discover old material. I mean, the simple little scenario that I think of is it's the year 3000, and I've just done a Google search and turned up a PowerPoint 1997 file. It's probably a good bet that PowerPoint 3000 doesn't know how to interpret PowerPoint 1997. I mean, no disrespect to our friends at Microsoft, but it's hard to maintain backward compatibility for 1,000 or more years. We don't have any experience with that, with the exception of things like papyrus manuscripts and vellum, where essentially it's the eyeball that's maintaining compatibility because we can still see it. But that isn't going to be the case with digitized material. So I guess a challenge for you, because you're part of our academic community and some of your job is to maintain this content, is to figure out or to challenge the academic community to find ways to assure that we'll be able to keep this information useful. Otherwise, over time, what will happen is more and more of that information will become uninterpretable, and so discovering it in a search isn't going to be useful, and that would be a bad outcome. I'd like to also suggest to you that we're seeing a major shift in the way information is offered to users. In the past, I mean this in the most general sense, I don't mean just network information, but think of all the media that you can think of, television, radio, magazines, print newspapers, and so on. For many, many years, the mass media had control over what the users saw and often when they saw it. We publish this newspaper every morning. The following television programs and radio programs are scheduled on following times and certain days. Not only that, but we'll determine which ads you see and in which order, on which pages, and when in the radio program or the television program do we interrupt your viewing enjoyment with a message of importance to the advertiser. It might not be important to you, but it's certainly important to the advertiser. That paradigm is changing thanks to this online internet environment. The users are deciding what they want to find. They are deciding what they're interested in discovering. They're deciding what transactions they want to engage in. They are the ones that decide what information of theirs that they want to announce and share. They are deciding, we are deciding, with whom we wish to collaborate and with which information we wish to do it. We're also seeing the emergence of a great deal more self-service. Now, I have to admit to you that I've often thought whoever invented the idea of self-service should get the Nobel Prize. I want you to think for a minute about the logic. First of all, you don't have to hire anyone to serve the customer because the customer serves herself. And if she doesn't like the service, it's her fault. So right away, you've removed two big pains in the business world. But it does put you in more control than you ever have been before, and it's because you can get information that you could not get easily before. For example, Amazon will share with you information about who else bought this book. Not who bought the book, but what other books did people who bought a particular book also buy. So it's telling you, in a sense, the zeitgeist of the time, who is reading what. FedEx helps you find where's your stuff, because they keep track of it, and if you have the accession number, you can find out where your package was last seen. It doesn't mean you know where it is, but at least you know where it was last seen. TiVo helps you control and decide which video you're going to watch. You download it and play it back later, which is very much the iPod generation. Instant messaging and global positioning services, navigators, and the like allow us to control in a more real-time way what we want to do, where we want to go. You've seen, I'm sure, on the web what it's like to look for real estate these days. You don't drive in your car anymore. You sit down on the net and you go and look at these 360-degree images that people take of the homes and buildings that they're offering for sale, or you can visit virtual museums that are pulled together and threaded in some sense according to artists or according to some other subject matter. So there is a very interesting, more user-oriented paradigm that's showing up. It may be very much the case that even in the educational world we're going to see a similar kind of thing happen. If we are able to use online techniques for people to learn, then they may decide what they want to learn and when they want to learn it, as opposed to I have to show up in class at 8 o'clock in the morning. So these things are inverting a great deal of the previous paradigms. And I have to say, in the advertising world, this has caused a good deal of consternation, because suddenly the advertisers have no guarantee that anything that they put up for advertising will ever be seen, because the users decide if they're going to click, for example, on an online ad. Now, the other side of that has turned out to be important, because it turns out that a user who decided to click on an advertisement has already shown interest, and that's a huge hurdle in the advertising industry. That's why advertisers are willing to pay more, in some cases, for an online ad that was clicked on than an ad that they put up on a web page that they aren't sure anybody looked at, or an ad that they put out in a newspaper or magazine. So this feedback loop is transforming the industry, and is transforming the way in which we as users are seen by the services and producers. I'm terribly worried, as I hope all of you are, with the apparent decline in enrollment in computer science or electrical engineering, and the general lack of interest in science and technology. Children, as you well know, are natural scientists. Their curiosity knows no bounds, and yet we somehow manage to kill that by the time they're in the 5th grade. And I suspect some of that has to do with our teaching methods. I hope we can find a way to reverse that. Some people will say, well, part of the reason nobody's interested in computer science is that all the jobs are going to India or Ireland or someplace else. And there may actually be some truth to that. Senator Dorgan wrote a book called Take This Job and Ship It, in which he talks about outsourcing and the side effects on the economy. It's actually an interesting and thought-provoking read. Even funding for computer science research has diminished over time. Some of the traditional places have been focusing much more on applications than on fundamentals. And I think that's also a potential serious threat. So what can we do about that? Well, do you remember, some of you are old enough to remember when the Russians launched Sputnik in October. Maybe it was October 4 instead of October 5. Did I get it wrong? I think, well, we'll Google it later. In any case, I'm pretty sure it was October of '57. I know I'm not supposed to use Google as a verb. Shame on me. I'm sure my intellectual property attorneys will have me burned at the stake when I get back to Google in Mountain View. In any case, you'll remember what happened. The Russians launched the first Earth-girdling satellite, and it was a real surprise for the Americans, who thought they were ahead in the space race. By January 31, 1958, we did launch our own satellite. The National Science Foundation started a massive program on science and technology enrichment, which was used heavily in the K-12 parts of our educational system. The Advanced Research Projects Agency was created by President Eisenhower and followed not long thereafter by the National Aeronautics and Space Administration. There was a real national focus on science, technology, engineering, and on the teachers of those subjects, and I can personally attest to the impact that program had. I went through enrichment classes in high school. I attended college at Stanford as an undergraduate, and you could see the ripple effects of those programs going through all those institutions. It was very powerful stuff, and it absolutely steered me in the direction of engineering and eventually computer science and networking. So maybe we need a new Sputnik. And I'd like to suggest to you that global warming might be a good horse to ride in this particular race. I'm not suggesting that you have to believe or disbelieve the question of global warming at all, although I will say that the evidence seems to be pretty strong. But suppose we said, okay, global warming is a real problem. Let's treat this as a national challenge in the same way that Sputnik was. Let's use this as a rationale for and a framework for improving the science and technology programs in K through 12. Think about, for a moment, even setting aside global warming, President Bush made the apt remark that we were addicted to oil. There probably was a time when he thought that was a good thing because he was in the business selling us the addicting drug, but now he recognizes that we are addicted to oil that comes from outside the U.S. Suppose that we made a major effort, a focus, a target on the design of fossil fuel efficient cars, or even power generation that doesn't rely on fossil fuel at all, something that significantly reduces our requirement for petroleum. Well, that would be a good thing because it would tend to remove the CO2 emissions, and it would also remove our dependence on foreign oil. Just to give you a statistic, in France, they produce 78% of their energy requirements with nuclear power, and so they do not have nearly the problem we have with our rapid need to ingest foreign oil sources. Well, if we were to say, let's solve this problem, because getting rid of the dependence on petroleum, or at least diminishing it, would actually be very beneficial for our economy. It would be beneficial from the global warming standpoint also. But it would require some pretty substantial computing to really do a good job. New algorithms would be needed to model not only the fuel-efficient alternative technologies, but also to understand better what's going on in the atmosphere, at the atmospheric and ocean interface, and for that matter, the side effects of warming on the currents of the oceans as we put more and more clean water, or I'd say non-salty water, fresh water, into the ocean system. It has a potentially profound effect on the way the ocean currents work. We could also be focusing and trying to reduce our dependence on this petroleum glut, would be teleworking and telecooperation, telemedicine, and so on. There are probably 100 other things that sitting here this morning you could invent that we could use as ways of stimulating people's interest in science and technology, and perhaps especially computing and information technology, all based on this theme that we want to reduce the use of fossil fuels, and as a side effect, try to move ourselves away from the potential inflection point where there's no way of stopping or even retarding some of the effects of global warming. Well, let me just finish up this morning's talk with a quick update on where we are on the interplanetary internet. Some of you have heard me talk about this before. Let me make sure you all understand that this is not a Google project, and you should not run away saying Vint Cerf says that Google's plan is to take over the solar system. That's not our business model. This is work that I've been doing at the Jet Propulsion Laboratory since 1998. We've done a pretty good job of instrumenting the Earth. We're very interested in trying to get more information about our nearby planet Mars. You know, we've used the Deep Space Network to do this. We've communicated spacecraft that are in orbit around the planets or flying past the asteroids. We've been putting things on the surface, like the Pathfinder in 1997, and more recently, the Mars rovers, two of them, Spirit and Opportunity, that landed in 2004. It's hard to believe that it's been almost 3 years since those systems landed. And what's incredible is that they're still working. Now, I've been quite curious about that. This is a sort of a technical view of what a rover looks like. You'll notice that the big black panels that look like wings are the solar power systems. These things have kept the rovers running for about almost 3 years now. Part of the reason is that they have been less dusty than we expected them to become. The dust does accumulate over time, and you can see it because the voltage levels drop. But then, suddenly they spike up again because somebody is up there dusting off the solar panel. Now, we haven't caught them on video yet. And some of the planetographers are telling me that my theory is probably not correct, and that more likely it's the little dust devils. These are little dust storms that come and actually blow the dust off of the solar panels. And in fact, you can see it if you're in the operations center at JPL in Pasadena, and you are watching what the reports are, the telemetry coming back for voltage levels from the solar power panels. You can see them suddenly spike upward again when there's a little dust storm that blows the dust off. So incredibly, these things have been able to keep going for much longer than we expected. Now, what you do, or some of you have heard this before, know that we don't have as many standards in space communication as we have for the Internet. The flexibility of the Internet is turning out to be pretty important for space exploration. You all know, I'm sure, that there are now 4 satellites in orbit around Mars. First 3, Odyssey, Express, and Polar Surveyor, have been there for some years. Mars Reconnaissance Orbiter is a new satellite just recently added to the system. There was a problem with the radios on the rovers. Originally, they were supposed to transmit all their data back directly to Earth to the big Deep Space Network antennas. at 28 kilobits a second. There turned out to be a problem with the radios. They actually overheated after about 20 minutes of use. They had to turn them off to keep them from breaking, and then turn them on for short duty cycles. And so that limited the amount of data that could be returned. Someone cleverly had put another radio on board which was suitable for communicating up to the orbiting satellites. The orbiting satellites were reprogrammed to be store and forward nodes. So now 95% of all the data goes at 128 kilobits a second from the rovers on the ground up to the orbiters, and then is retransmitted back to the deep space network at the higher speed. So we're getting more data back as a consequence of putting in store and forward networking. But this required retrofitting software into the rovers and into the orbiting satellites. It's a good thing we were able to do that. But the theory behind this project is we should just make that a standard. We should standardize this whole process so that every time you launch a new mission, it becomes part of a growing internet backbone. Well, we're at the point now where this project has gone on for about 8 years. We've been through several iterations of the protocols. They're very stable at this point. We've been doing terrestrial testing, not only with radio, but with even acoustic transmission underwater. There's even a project up in the northern part of Sweden where we've been putting these protocols in laptops on the backs of snowmobiles and putting up 802.11 Wi-Fi systems in the villages. And so we're using the interplanetary protocols to deliver information. It's a very erratic thing. You know, a snowmobile shows up, dumps whatever it's got, picks up anything else, and goes to the next village. There's no schedule for that. It's not like a little data mule is going around on a regular basis. So it's a very random process, which is very much like the kind of disruptive communication that we experience in some parts of the space effort. So the lower layers of this interplanetary internet are already on board the Mars Reconnaissance Orbiter, and when it finishes its primary task, which is to map the surface of Mars, help us find whether there are places where water is likely to be, it could be reprogrammed to become the first node of a two-planet internet between Earth and Mars. So I think it's now ripe for space-based testing. As time goes on, I hope that once these protocols are adopted, that we'll have them on board all the new spacecraft that go out to the outer planets, and each time we launch another mission, we'll be able to make use of the previously launched resources to build up slowly over decades an interplanetary backbone. So that's the status of the interplanetary internet. Let me stop here. Let me thank you very much for allowing me to join you this morning, and if there is time left, I'm happy to engage in some interaction. Thank you very much. So, Mr. Moderator, do we have time for anything, or did I overstay my welcome?
We do. Are there any questions anybody would like to ask?
I hate to think that I'm the guy that has all the answers, so if you have not a question, but an assertion or a flamboyant claim, that would be okay too. There are some microphones in the back there, so if you want to just, or in the middle. Is this microphone still working? Can you hear me in the back?
Yes.
I can't tell. You can't? Okay, that's good. The usual question is, can you hear me back there in the rear? And the answer is no, we ain't built that way. Gotcha. Yes, sir.
You had mentioned earlier that the media that used to have control of what we saw has given way to a more democratic internet. Can you say something about what you think the current net neutrality issue effect will be on this?
Thank you very much. In fact, I had a note to remind myself to mention that, and I didn't, so thank you for bringing that up. The term net neutrality, it may turn out to be less of a grabber than another term which I'll call internet freedom. The basic issue right now is that for 15 years or so of the commercial internet, since 1989, the net's been very open. Any user who got onto the net had reason to believe that that user could get to every internet destination and interact with it. This is very important for the academic institutions of the world because you want to be reached by anyone who has an interest in the information that you have in the services that you offer and the educational products that you produce. And so it would be very disappointing, if not alarming, and maybe even downright bad, if somehow this openness and equal access diminished. For many years, the internet was based on dial-up, and it was very easy for you to switch from one internet service provider to another by simply dialing a different number. But of course, that was slow. Now we have broadband, but we don't have very much choice in the way of broadband services. Typically, you might have a choice of two different providers, a cable company and a local exchange carrier offering DSL in this country. In fact, some 10% of the country has no choice at all because there isn't any broadband, and about 30% of the country has a choice of only one or the other but not both, which means that you don't have a whole lot of competition for broadband services. That in and of itself isn't necessarily bad, except that some of the local exchange carriers have announced that the cost of their broadband system is so high that they don't want to charge the subscribers the full cost. Instead, what they want to do is go to those who offer services on the net, including you, and charge you for your users access to broadband. Now we have an interesting problem because the ISP is the provider of the broadband service, has bottleneck control over it, and could decide to differentially charge, possibly giving better service to those parties who will pay for the subscriber to get access to that serving party over the broadband system. At Google, we and many of our colleagues in the industry think this is a really bad idea because it will diminish innovation. Two guys in a garage, Larry Page and Sergey Brin, could not have purchased broadband access to the internet for the users, the billion users all around the world, to get access to Google. All they did was put that system up, and everybody had a chance to get access to it. So I am very concerned if there is movement in the industry towards kind of curtailing what the users get in the way of choice over the broadband facilities, which they have been told give them access to the full internet. And although the campaign went under the term net neutrality during this session of Congress, next year, so far no legislation has been passed, so the threat still is dangling. Next year, I hope that we recast this as a serious issue for users who are expecting to get full access to the internet when they pay for broadband services. Yes, sir?
You talked a little bit ago about the ephemeral nature of digital information, both in terms of formatting and storage medium. I've already seen this as a problem in my organization. What would you suggest for technology planners we do to deal with this over time?
This is a really tough problem, and the reason I brought it up was to try to stimulate some thinking. First of all, it's clear that the capture of the bits and moving from one medium to another is fairly straightforward, and we do it all the time. We buy new disks with new technologies, higher densities, and we just copy the bits. So I don't see that as a very serious problem. The serious problem is the ability to interpret the bits and even to know what software had produced them. I don't know how many of you are Apple fans, but I'm sure that there's a fair significant fraction because the academic community tends to be pretty favorable towards Macintosh. The reason I bring this up is not to sell Apple or Macintosh, but to make an observation about the way they store information on the disk. There's several pieces of information in addition to the file. They also record information about which program it was that produced those bits, and so that data is bound to the storage of the actual file itself. Styles like that strike me as being very appropriate. In a sense, it's capturing knowledge about the origins of these bits, the version of the software that was used to produce them. Now, that knowledge in and of itself doesn't solve the problem. It doesn't help in the year 3000 to know that the program that produced this 1997 file was called Microsoft PowerPoint 1997 or 1995 or something, unless that means something, as in here's how you get a copy of the program or here's how you go and execute that program online. So my suggestion, just as a beginning opening dialogue, would be to come to or talk to the producers of software and say, When you stop supporting this software or that particular version, would you consider putting it in escrow so that it is remotely accessible somehow? If you don't want to support it anymore, at least make it possible for people to still run the software. I think that that's an opportunity for network-oriented services where we don't necessarily all have to have a copy of every piece of software that ever produced anything, but rather, as we store information in the network environment, we also store the software which produces it. And this is going to take a certain amount of agreement over intellectual property, but it seems to me it's irresponsible to allow ourselves to move ahead in the production of all this digital information if we don't find a way to make it useful over the long term. So that would be my first choice, is to try to begin that process. We may need to rethink what copyright means in the digital environment. I had a very interesting lunch session with James Billington, who is the head of the Library of Congress and implicitly is responsible for the Copyright Office. He too is interested and concerned about this problem, and I think could be persuaded to convene a discussion on the subject. So if we get the American Library Association, Educause, and some others like the Copyright Office and the intellectual property industry to sit down and just discuss what the issues are, maybe we can uncover ways of solving this problem in a fashion that is satisfactory to everybody. So thank you for that question. I have one more over here. Yes, sir. Yeah.
As more and more personal information is stored on remote servers, what is the implications for the loss of privacy for that data?
Yes. If anyone here thinks they have any privacy, let me tell you, you probably don't have much left. Americans, by the way, are peculiarly willing to give up our privacy in exchange for convenience. I can prove this to you, those of you who have credit cards, because at the end of the year, when you look at your annual report from American Express or Visa or what have you, you can throw away your calendar because it says what day you took the plane, which hotel you stayed in, what restaurants you went to, and where you went shopping. It's all there. There are big implications for privacy, and this current generation of Internet users, let me call them the iPod generation, the MySpace generation, seems to think that it's actually cool to share a substantial amount of information about what they do and what they think every day. And I look at that and I remember, my own teenage years, and I can appreciate the me-centric aspect of that time of life. But then I'm looking at this from the viewpoint of somebody who's several decades old now, thinking, God, I'm glad that I didn't put any of that stuff up on the net when I was 15 or 16 and filled with hormones and everything else, to be discovered later when I'm being considered for an important position, a position of responsibility and decorum. So I don't know what's going to happen to this generation that's sharing so much of its secrets. And we won't know, so we'll all be dead before this happens. But when they get to be our ages, taken generally speaking, then we will discover how much they wish that they had kept that stuff private. So the real answer, I don't mean to be flippant about this, the real answer is it's very hard. We do need to train people to think twice about what they put up on the net. The reason for this example is identity theft. This is not stealing money from out of your pocket or your bank account. It's stealing money from the credit granting institutions who hand out these credit cards, some of which are being given to people who claim to be you but aren't. And of course they spend all the credit and then they don't pay it back and you're blamed. That's a bad thing, and I'm told that it's a $200 billion a year problem. So we really do need to start rethinking what privacy means and what we should do. Let me just underscore something about information, personal information, which is normally collected in the course of business. When you deal with Amazon and you want them to send you something at home, you have to give them your home address to do that, otherwise they don't know where to send it. That's corporate information, which Amazon, and I believe they do, keeps private. They don't treat that as information that should be put up on the net. So you need to be thinking about how we educate the business community to recognize that some information which is private and personal should be kept that way as a business decision. This has less to do with laws than it does with business ethics and common sense. So I hope that we can begin to train people to understand that things online are different from things on paper. When you file a design for your house to make sure that it meets building codes, the fact that it's on paper in an archive somewhere and it's, quote, a public document, usually doesn't leave you with too much concern because very few people are going to go down to the county courthouse or to the county registry in order to look at your plans. But if they're all online and somebody can discover them by simple searching, then suddenly the details of the security system of your house are of much more concern than they were before, because you don't want the whole world looking at that. So our definition of what's personal is going to have to change simply because of the accessibility in the internet environment. Actually, that's all the time we have, isn't it? Yeah, I'm sorry, we'll have to do this later, but thank you very much
Let's
again
thank
for
Vint
allowing me to be here.
for a great presentation.
I'm sorry, it takes a few minutes to completely disconnect myself from the wires here. So much for wireless, right? In fact, that's also true for the power supply here. If the house lights go out, it's because I just pulled the wrong plug. And behind the podium.
He just said, pay no attention to the man behind the podium down there. And we ought to thank him also, not only for this morning's presentation, but for giving us all careers, okay? I do want to point out a couple of logistical items. First